Alright, page 192, number 9. F of x equals x squared plus 1 over x squared minus 1. And the directions say, determine the open intervals on which the graph is concave up or concave down. So concavity intervals. Well, concavity is a second derivative thing. So I'll need a second derivative, which is going to be kind of a pain for this guy, but whatever. Second derivative, I'll figure out where that's 0 or undefined, set up a number line, test the intervals. So quotient rule, f prime is 2x, g prime is 2x. Maybe that'll make some things work out, we'll see. So quotient rule is gf prime minus fg prime all over g squared. Okay, so 2x cubed minus 2x minus 2x cubed minus 2x. Okay, so that's not awful, I guess. Negative 4x over x squared minus 1 squared is our first derivative. Now we get to do it again. For the second derivative, f prime is negative 4. G prime I'll need to be careful with. 2 times x squared minus 1 to the first times 2x, because of the chain rule. So gf prime, so now the second derivative, gf prime minus fg prime. Okay, see how much algebra I can do at once here. Minus a negative is going to be plus. 4 times 2 times 2 would be 16 x squared times x squared minus 1 all over the square of g, so that's going to be x squared minus 1 squared squared, or to the fourth. Lovely. So cleaning up the top. I think I'm going to factor out a 4 for sure, and the x squared minus 1. So that would leave, I'm trying to decide if I want to take out the negative or not. Doesn't matter. Negative x squared minus 1, because there were 2 of them, I took one of them, plus 4x squared, but I took the x squared minus 1 all over x squared minus 1 to the fourth. Alright, any point in here I could stop. If it just asked for the second derivative, I would safe stop this and just say, done with this thing. But I need to know where the top is 0 and where the bottom is 0, so that's why I keep going with the algebra, hoping to get somewhere nice. One of these will cancel, so x squared minus 1 will go away, or one of them will, and that leaves x squared minus 1 cubed in the bottom. And in the top, let's see, negative x squared plus 1 plus 4x squared, so that would be 3x squared plus 1. think my algebra is correct there. Okay, so I'm thinking number line, but I need to know where the top is 0, where the bottom is 0, because those would be the potential breakpoints on the number line. So top equals 0. Well, that's not going to happen, because if I square something and then add 1, that's always going to be positive. So nowhere is the top equal to 0. I guess that's good. That's one less point to put on the number line. The bottom, that would be where it changes, where it's undefined, where the second derivative is undefined. X squared minus 1 cubed equals 0. So if I cube root both sides, I'm looking for where x squared minus 1 is 0. So that would be plus or minus 1. My potential breakpoints, I guess. So my number line has -1 and 1 on it. And I want to test the second derivative because it asked me for concavity intervals. So I'll check -2 and 0 and 2. And I need to check them into the second derivative. I guess if I'm really paying attention, I already said the top is always positive. So it doesn't matter what I plug in there. Square it, multiply by 3, add 1. The top's positive. The bottom I've got to worry about. I plug in -2. Square it, I get 4. 4 minus 1 is 3 cubed. Whatever that is, it's always positive. So f is concave up on that interval. If I plug in 0, again the top's always positive. The bottom, I end up with -1 cubed, which is negative. So f would be concave down, because f double prime, the second derivative, was negative. And if I plug in 2, positive over, oh, this is the same thing if I plugged in -2. 3 cubed, positive, so concave up. So I guess to fully answer the question, it's concave up from -infinity to -1, and 1 to infinity, and it's concave down between -1 and 1. And it doesn't tell us to check that on a calculator, but it's really easy. Well, maybe not really easy, but it's easy enough to check that on a calculator. X squared plus 1 divided by x squared minus 1. And I probably only care about close in, so we'll go -5 to 5. No idea what this graph looks like, but let's check the concavity. Oh, that matches. All right, it's concave up over here, concave down in the middle, concave up on the other side. So, you know, the calculator's no guarantee we got it right, but I feel like it's helpful to look at the graph and see that, yeah, that matches all this work we just did. It matches what the picture says.